right, we are picking up in the 1-7 notes. Let's finish these up so you guys can have some work time. We were talking about 3D figures, surface area, and volume. Okay.
Excuse the interruption. Would Miriam Goldwasser, Sydney Stewart, and Sydney Bailey please stop in the office?
So, surface area. Remember that one's like the wrapping the present. You're trying to figure out how much area it takes to cover the whole figure, all the sides, all the bases. Okay. So let's start with this one. Ooh, who wants to classify this for me? Go ahead, Noah.
Trapezoidal prism.
That's your one, trapezoidal prism. Good. So my bases are these trapezoids. Okay, so I have two of them. So I have to double this. Area of a trapezoid is 1/2 times the height. Height of this trapezoid is 12 times the sum of the two bases. All right, so I look at my picture for those dimensions. It looks like the top base is 18 feet. And my bottom base is 23. Okay. So I always like to start with my bases. Then I like to do all the other sides. So like the front to the back, left, right. But here the front and the back are my bases. I'm going to kind of start with this top rectangle, which is length 18 times width, which looking down here, that's 15. So it's kind of like my top. The bottom, another rectangle. That one's clearly 23 by 15. Okay, everyone with me? And then we have what I like to call like the left and the right. These two rectangles. So my left, that would be 12 by 15. And my right, 15 by 20. Area of a rectangle, we just do length times width or base times height. Okay. I got a total answer of 1,587 feet squared for that surface area. All right, our general rule of thumb to find volume is we can do length times width times height. However, here with this trapezoidal prism, you're like, length. Is this my width? Is this my height? But that doesn't make a perfect rectangle, right? I kind of have like this piece missing here. So that's when we have to do that second formula we talked about yesterday, the area of the base times the height. Okay. Remember our base is a trapezoid, so we already found that right here. 1/2, 12 times the sum of our bases. Now I don't need to double that because I'm not talking about both bases. It's just, this is my formula, area of the base times the height of my 3D figure. Well, if these are the bases, how tall that is would be 15. All right, so I got 3,690 feet cubed for volume. Okay, lots of formula use. Now I'll get some more. There are some formulas too you'll be given on like the test because you can't use your notes on the chapter 1 test. We'll worry about that kind of next week, which formulas you have to know and which ones will be given to you. Obviously, quizzes, you get to use your notes, so you have them all there for you. All right, now with cylinders, because these aren't polyhedrons, we have these special formulas for surface area and volume. So these would be like ones that would be given to you, okay? So the surface area for a cylinder, our can of soup one, is 2 pi RH plus 2 pi r squared. R standing for what?
Radius.
Radius. What's my radius in this picture? 11. Good. H standing for what? Height. What does it look like? How tall is that can? 26. Good. So we're going to plug 26 in for the height, 11 in for the radius, plus 2 pi my radius squared. Okay, as I mentioned, you're going to get a ton of practice with typing this in your calculator and stuff, so to save time, I'm just going to give you that answer, but you would have to use the pi button. I got approximately 2,557.3. Since you're talking about area, this would be yards squared. Oops, it looks like that yard got cut off. This one. Okay, volume of a cylinder is pi r squared times the height. So for these ones, I just say, you just plug and chug your number here. My radius is still 11. My height is still 26. And I got an answer of approximately 9,883.4. Usually we just round to 1 decimal place unless they specify otherwise. Volume, yards cubed. Okay. Now it's not bad. That's just using our formulas. Let's move on to this square pyramid. Surface area. We just find the area of all our pieces. So I'm going to start with the base. Now with pyramids, we only have one base, right? So I don't need to double this. This is a square, so just be 8 times 8 or 8 squared. There's my base. And then you just need to find the area of the triangle. Now the nice thing about pyramids is that all those triangles are going to be the same. So we just need to find the area of one of them, and then we can times it by how many triangles there are, right? Just like we do with the bases when we double them. So let's look at one of these triangles. This one right here. So area of a triangle is 1/2. My base is 8. And my height, they're showing me right here, that forms the right angle with the triangle. That'd be my height of that triangle, is 11.7. Okay, now how many triangles do we have on this pyramid? You can shout out.
4.
4, right? So we have to times this by 4. That's the easiest way. You don't have to memorize a formula for finding surface area of a pyramid. Just add up all the areas of the polygons. Okay, ready for this number? 251.2 meters squared. Now the volume for pyramids, we're still going to do the area of our base times the height, but we're only going to take 1/3 of this because it comes up to a point of a vertex here. All right, this is kind of our formula for volume of pyramids. 1/3. Okay, my area of the base, we found that right here. 8 squared times the height of my period. Now, this is a common mistake. The height of that period is not 11.7. Okay, we kind of go back to our diagram here. That L that they're showing this picture, that's something we call like our slant height. Okay, it's the height of that triangle. If we want to know the actual height of the pyramid, we'd have to kind of think, okay, if I took a perpendicular line coming right down from the vertex and landed it perfectly perpendicular at the plane, that right there would give me my height of my period, or my pyramid. Periods, I'm talking about sine and cosine trig graphs. What am I thinking? Okay, so here, what we need to find So everybody take your pencil, put it at your vertex of this pyramid, and drop down a perpendicular side to the plane. It would land right in the middle of this square. We could kind of form a little right triangle here, and this is my height. All right, so let me kind of blow up that triangle for you. What we have here, we have that perpendicular height that runs across my base here. And then I have a hypotenuse of that 11.7. All right, now here's a cool thing with these. Anytime you draw a height straight down, it's going to end up right in the middle of your base. So if this distance is 8, what would half of 8 be? This distance would be 4. Yeah? All right, I'm going to do a little Pythagorean theorem here to find the height. So I would do h squared plus 4 squared equals 11.7 squared. Again, to save time, you guys know how to solve these. I got that height to be about 11. Okay, so be careful on those ones. And we're going to do one more like this. But that height would be 11. About 11. Okay. And for that final answer, I got 234.7 meters cubed. Okay, we only got 4 more to go. I know math isn't the most exciting read. You just have to do example after example after example, but that's the best way to kind of apply your formulas. You just got to see all the different types of scenarios that come up. What do we got to use when? What shape is this one? A cone. Good. Okay, so cone's not a polyhedron, so I can't really add up this area around my cone. So this one has a special formula, and I'm just pulling it from that table that I gave you guys. Okay. It's pi r cursive L, that stands for that slant height, we'll get there in a second, plus pi r squared. Okay. What's my r of this cone?
7.
7's my radius. Good. So you can plug that in. L is the slant height. So that would be this height right here that runs along my cone, 11.4. All right, I'll flip back just in a second here, but we can see in our one for cone, that distance right here, that's what we call that slant height. That's given to us. I just took that formula right from here. Okay, for our volume, we need to know the real height of the cone. So we'll probably have to do another one of those triangles, but we're not there yet. Okay. Crunching that number in my calculator brain. 404.6 meters squared. Okay, now here's a cool connection to make. So we found the volume of the pyramid in the last one. We had to take like a third of the base times the height of like a normal prism. So to find the volume of a cone, think of what we did for a cylinder. We did pi r squared times the height. For a cone, we just do a third of it. Okay, so those are kind of some good connections to make here. Sorry, I know you don't have a ton of room to write on this one. Okay, we know our radius is 7. Now, H stands for the height of my cone, which is not the slant height. That'd be this height right here. So this one's a perfectly like drawn to scale. We can see that right triangle. Everybody see it? We know this is 11.4. We know this is 7, my radius. I'm trying to find this. All right, Pythagorean theorem for you quick. I got about 9. Okay, again, that's something we already know how to do. So for my final answer for that volume, I got 461.8 meters cubed. Okay. Last one here. What type of polyhedron is this one? They're not numbered. This one right here. How do we classify that? Ariana? Pentagonal prism. Good job. The bases are pentagons. Hey, what does this capital B stand for?
Base.
Okay, but what else? What did it stand for right here?
Is it like the area of the base?
Yeah, it's the area of the base. Isn't that nice? We don't have to find the area ourselves. Okay, be on the lookout for that. Also, it's in your chart here too. Capital B is the area of the base. Okay. So, in this example, my area of the pentagon is 84.3, so you don't even have to calculate it, but we do have to double this to add up the areas of my two bases. Okay? Now we just have to add up the area of all the sides. Now look at these markings here. They're showing me that this pentagon is a regular pentagon, meaning all the sides and all the angles are congruent. So since the height of this prism is 4, can you guys see that all of these rectangles are going to be the same?
Yeah.
They're all going to be 4 by 7, right? Nice. Okay, so 4 times 7. How many rectangles are there?
5.
5. So we just have to times that by 5. Okay, I got about 350.7 centimeters squared for that one. I'm just going to zoom in here. Sorry, there we go. Volume. We can normally do length times width times height, but you're like, I don't have a length or width here, so we're just going to do our area of our base, which is nice because that was given to us, times the height of our prism. Area of our base was 84.3. Oops. Times the height of this prism, which it looks like the height. This is 4 tall. And that adds that 3-dimensional piece of it to the figure, right? That's what calculates our volume. Here we're just talking about the pentagon, and then once we times that by 4, now we're calculating all that space that it takes up in that prism. All right, that volume I got to be about 337.2 feet cubed. Two more. Got this. So you can kind of start seeing connections with the formulas. Go back just for a second. Where you can find the area of anything by taking the area of the base times the height. Okay, when I have like the pointy vertex in my shape, I have to take 1/3 of the volume of what I would normally do for like a prism. All right, so what I would normally do for a cylinder, for a cone, I just take 1/3 of that. Whatever I normally do for a prism, for a pyramid, I just take 1/3 of that. Okay, because it's obviously we're losing space when it comes up to a point versus having two parallel bases. Okay, can I see that connection? All right, a couple sphere and hemispheres is all we have left, so we're just going to use these formulas. Again, these are probably ones that would be given to you on a test, but you have your notes for the quizzes. Is this one a sphere or a hemisphere? A sphere, right? All right, here's the surface area for a sphere. 4 pi r squared. Now, the only thing that makes this one a little tricky is that they don't tell us what our radius is. What do we call this length? Diameter. Okay, what's the relationship with diameters and radius?
Diameter is twice as much as the radius.
Exactly. Diameter is twice as long, or the radius is half. So if the diameter is 33, the radius is going to be half of that. That number is 16.5. Okay, so that's all I had to do for that. Crunch that number. You get about 3,421.2 centimeters squared. volume of a sphere. Another. With anything that's like round, you guys, with like cylinders, cones, spheres, those formulas are just ones you have to like use, just plug and chug, as I like to say. Like there's no like visualizing of like the shapes of that we're adding up. Okay, there's the formula for the volume of a sphere. We know the radius is 16.5. Do you guys know how to do cubed on your calculator?
Yeah. You just click up there on the cube.
Yep, exactly. So there's this up arrow that's right below your pi button that looks like this. So you would do 16.5, up arrow 3, and that would take it to the power of 3. Times by pi, times by 4/3. Do you know how to type fractions in your calculator?
Yeah.
There's this button that... Is it this one? That button?
Mm-hmm.
Yeah. Okay, so if you want to try and plug that one into your calculator quick, just make sure you're on the right page. But like I said, you're going to get plenty of practice on your homework. And once you start getting work time the last half of class here and you're getting some weird answers, I can help you with that. Make sure you have the correct units, centimeters cubed. Okay. Hemisphere, I had you fill this one in on your table. And then I kind of mentioned that a lot of people think it would just be half of the surface area of a sphere, but it's not, because now we have this portion right here that we also have to like calculate in the area. So I do half of pi r squared, but then I have to add in this area of that circle, which is another pi r squared. So the surface area for a hemisphere is 3 pi r squared. Okay. And again, in this example, they don't give me my radius, they give me my diameter. So my radius would just be half of this, which is 6.1. For surface area, I got 350.7 centimeters squared. Volume. When we're talking about space, you have a whole globe that's filled with water. You slice it right in half. You have exactly half of the bowl still filled. So your volume for a hemisphere is exactly half of this. So half of 4/3 is 2/3. Pi r cubed. 6.1 is still my radius. And some more calculations. 475.4 centimeters cubed. Wow. You guys, that's all for chapter 1. Can you believe it? Not even a month into school, we finished the whole chapter already. Any questions on this stuff? Obviously, I can't stress enough how this is just a lot of formula work, but when you can logic your way through surface area and volume, do it. But when we get to shapes that are not polyhedrons, we have to use our formulas. Okay, that's a wrap. I'm going to stop this recording quick. You guys can get started on working. Hold on.